Welcome back. It's time to bring back our logarithmic properties. Note that first step asks us to condense all of our logarithms. If I take a look at number 4 here, note that there are 3 logs in this problem as opposed to the 2 we had in the 3 previous examples. So it's time to bring back some properties. Remember, addition on the outside becomes multiplication inside. So I can condense the logarithm in number 4 here. Too far down. I can condense the logarithm in number 4 here. This will be the same as log of 4 times y plus 5. We'll go ahead and make that one red. Again, that was this guy on the left, and the 4 is this one here on the right. So addition on the outside becomes multiplication on the inside. So now we're good to use our bases property, our one-to-one property, because I have the same base. If you're looking at these logs and you're like, well, Mr. Lofthouse, they don't have a base. Remember that a log with no base is really a log base 10. That's called our common log because it's the most commonly used one. So log base 10 on both sides, well, that means we can go ahead and set the insides equal. In the future, we will end up skipping this extra logarithm. The only reason I'm writing it now is to show you where everything is coming from. Generally, once we know we're going to have common bases, we just go ahead and set up the equations. So notice on the left we have a distributive property. No big deal. 4 times y is 4y. 4 times 5 is 20. On the right, nothing interesting happens. This becomes a 2-step equation. To get rid of the plus 20, we can subtract 20. Goodbye. And that leaves me with 4y on the left. And it leaves me with a 52 on the right. Last but not least, divide both sides by 4. And 52 divided by 4 will be 13. Remember when you go back to check your work that your calculator has a button for log base 10. It's on the left-hand side there and it just says log. So you don't have to go through the log base menu to do a common log. So I've gone ahead and entered both of those with the 13 in place. Note that I did get the same number for both, so this solution does check out. So that was a good addition turning into multiplication example. Let's also take a look at an exponents example. Again, step 1 is to condense, and it's important to remember this property. Coefficients outside become exponents inside. So that 3 is going to become an exponent on the 4. Note that I have common bases. Both of these logs are a base 7. So we're good to go ahead and set up the equation. 4 with an exponent of 3, remember that's the 3 right here. That's going to equal 4a minus 8. So there's a bit we can do to clean this up. First things first, 4 cubed, that's a value we know. 4 cubed is 64. The opposite of minus 8 is plus 8. 64 plus 8 will be 72. And last but not least, to get that a by itself, we can divide both sides by 4. 72 divided by 4 is 18. Now you would want to double check that this 18 does in fact work. In the interest of time, I'm just going to go ahead and tell you that I've already checked it and it does. I encourage you to go and check it though. It's a good practice to get into. So we've looked at a problem where addition became multiplication. We've looked at a problem where coefficients became exponents. Let's look at one last example of a problem where properties are required, and it's the dreaded subtraction one. So the property that comes into play here is that subtraction outside becomes division inside. We know we have the same base for all of them. So we're good to go ahead and set up the equation. 68 over 4 equals 3n plus 11. Again, that 68 is coming from right here. The 4 from there. And last but not least, this expression from the right. So we can clean this one up a little bit. 68 divided by 4 is 17. And now I'm just left with a two-step equation. My two steps will be to subtract 11. Goodbye. 17, take away 11 is 6. And then last but not least, to get that n by itself, we can divide. That leaves us with a value for n. 6 divided by 3 is 2. Once again, I do encourage you to take that 2, substitute it back into the original equation. You can go ahead and use your calculator for that. To keep this video short, I'm just going to say goodbye for now.